Hi everyone. Today we'll learn what is regression and what is classification models. We are going to, learn about this topic. So I'll just start with my introduction. So hey everyone, I'm Neha and I'm working as a senior data scientist with KPMG UK, and I have completed my masters from IIT Madras in 2014, and since then I'm solving this data science problems. So I have worked as a consultant with a lot of clients in financial services, in the healthcare, and manufacturing, engineering, and aviation domain. So my primary work has been around in NLP, natural language processing, in deep learning models, and artificial intelligence models. So that's pretty much about me. So let's directly dive into the topic. So, so what we are going to learn here today is what is regression, what is classification, and trying to understand what's the difference between the two, right? So we'll also understand why there is two classification, right? And then how do we solve such problem? And we'll hopefully by end of this video you should be able to have a clear understanding if a problem is given to you, so whether it is a classification or it's a regression kind of a problem, so that you can choose appropriate kind of algorithms and evaluation metric. With that, let's get started. Right. So just to give you a quick overview, so this machine learning problem, it is broadly divided into two categories. One is supervised machine learning and another is unsupervised machine learning problem. So what do you say is supervised learning problem, which means that there is a target variable. You know clearly what needs to be done or what needs to be predicted, right? So for example, let's say you are trying to predict house price, you are trying to predict temperature, what is going to be temperature tomorrow, right? So all these are target variable, your dependent variable, which is already there and you know what you have to predict. However, on the other hand, the unsupervised machine learning problem is, as the name suggests, it is unsupervised. There is no defined target variable. There is no defined dependent variable. What you are going to do or what you are trying to do, it is not clear. So, to give you an example, like clustering, right? So clustering, so for example, I gave you a customer base data. Now there is no clear or defined y or target variable. It's just that it could be that we are trying to define customer segments, so that we can suggest, we find those unique clusters and then we can run our market campaign or sales campaign according to their behavior, right? Or it can be association rules. So for example, we do market basket analysis. So just like, let's say you have bought something, and then let's say this is the new thing which you are going to buy, right? So based on your previous transaction history, we simply do that mining of all those rules, that if a person has bought A and B product together, it's more likely that that person will buy a product C. That is called as MBA, it's market basket analysis, right? So this comes under unsupervised learning. However, today we are going to focus more on supervised learning, and that too within supervised learning there are two major division. One is classification and another is regression. So let's understand what is why there are two further classification between regression and classification, right? So as I said, supervised learning, it's basically, as I said, supervised learning, it is dependent variable which you are trying to predict. Right now, within the dependent variable, it can be into two categories. It could be a continuous variable or it can be a discrete variable. When it is a continuous variable, right, for example, something which you can measure, like height of a person or price of a house, temperature, all these you can measure, right? This is nothing but a continuous variable, and this kind of a target variable if you have, then it is called as a regression kind of a problem. However, on the other side, if your target variable is a discrete variable which you can count, like, so for example, rating of a movie or rating of a book, or let's say, whether that will happen or not, yes or no, these kind of classes when you have to predict, right, that is called as a classification problem. Okay. And why it is important, right? First of all, why it is important? Because it's a dependent variable, right? Why do I need two kind of different variables? Because your algorithm, which algorithm you are going to predict, right? And what is your model performance criteria, all these things are very very important, and it depends on what kind of problem it is. And that's the reason we have to really understand, whenever we are trying to solve something, whether it is a regression problem or it is a classification problem, so that accordingly we can choose algorithm, accordingly we can choose evaluation metric, right? So let's try to understand a little bit more about what is regression, right? As I said, whenever your target variable is a continuous variable, right? So for example, income, your scores, height or weight, all these are problems that cause a regression problem. Okay. So just like an example, if let's say you have a university and within that university you are trying to predict somebody's height, student's height based on their weight, gender, diet or any other features, this is called as a regression problem, right? Because your dependent variable is a continuous variable. However, classification, it could be labels or categories. It's basically a discrete output variables. For example, if an email is a spam or not spam, a movie rating which is between 1, 2, 3, right? So all these are called as a classification problem. So if it is two classes, like just yes or no, like a email spam or not spam, or whether that will happen yes or no, it's called as a binary classification problem. However, if there can be multi-class classification problem as well, whenever you have more than two classes to predict. So as I said, movie rating, whether it will be 1, 2, 3, or it could be, let's say, somebody's ethnicity we are trying to predict, or something else where you have multiple classes, more than two classes basically, right? So now let's try to understand. So we have understand individual level what are these two things, right? Regression and classification. But how do they really differentiate, right? So as you can look at this here in the chart, you can clearly see the regression is something it's basically a line which you have predict, right? So it's a parametric equation which you are trying to fit. So based on every x value, right, you are trying to predict what will be your y. So just for the simplicity, I'm saying assume that it is just a one single variable equation, and you can see for every value of x you have a value of y, right? So that is something which you are trying to predict in a regression problem. However, in a classification, you are not actually trying to fit this line. However, you are trying to fit the boundary, right? You are trying to fit the decision boundary so that you can differentiate what is your class 1 versus what is your class 2, so you can separate these two classes. And that's the fundamental difference between the two, right? And I mean, just so you know, so I'll give you, so it depends on your problem, right, on your understanding how you want to solve a problem, right? So I'll tell you, a similar problem can be solved as a regression problem and as a classification as well, right? So as you can see here, you can see here, so let's say if you want to predict what is the temperature going to be tomorrow. So if you are going to predict the temperature at scale, so basically, which means that if you are trying to predict what will be the temperature value, then it's a regression problem. However, the same problem can be converted into a classification if you predict that whether it's going to be hot or cold tomorrow. So okay, so for example, let's say you have decided a threshold, and based if it is less than that, then it's a cold. If it is greater than that, then it's hot, right? So then your target variable becomes hot or cold. So it becomes two classes rather than a continuous value, and that's where it becomes continuous. So it's a regression problem, and it is a classification because it becomes discrete, right? Similarly, let's take house prices. So if you choose that based on certain feature like what is the locality, number of floors, number of rooms, whether it has garage or not, so based on these features, if you're trying to predict what will be the cost of a house, what will be the price of a house, then it's a regression problem, right? However, on the other hand, let's say you have divided your price range into three classes: below average, average or above average, right? So then you have three classes over here. So it becomes a classification problem now, right? So it essentially depends on how you treat your target variable. A problem can be converted into a regression or a classification, as I said, right? So because like it's up to you how you want to treat your problem, because your algorithm and evaluation metric depends on whether it's a regression or a classification.